Hello and welcome. This is a video to showcase our project. It is the right time for us to groove into the concept called renewable energy. Talking about renewable energy, what strikes in mind is the solar and wind. Now, behind these two major sectors, there are lots of disadvantages. What we have personally done is we have implemented our ideas in order to improve the efficiency of the whole system. We have given a prototype model of a hybrid solar and wind system. We have implemented our ideas in the same system, and we have also modeled and controlled the whole setup. So our main project's title is Model and Control of the Solar Hybrid System along with wind and the implementation of our designs. Now, this is the setup. First of all, talking about our implementation, what we have done is we have tried to track solar as well as the wind system. Talking about the tracking system, here we have fixed by means of groove and gear arrangements a 12-volt 1-amp DC motor. Now this will track the windmill in a direction, and for tracking the same we have used a sensor there. That is called the wind sensor. It is a very simple logic behind the sensor. Now what it mechanically does is the arrow mark points the direction of flow of the wind. Now whichever direction the wind has higher intensity, the arrow mark changes and aligns itself into that direction. Now when the direction changes to another position, the tracking setup of the windmill itself changes to that respective position, and this is done by the DC motor 12-volt 1-amp. Now, talking about the tracking setup installed in solar panel. Before that, let me explain what we have implemented as design parameter. That is the implementation of the reflectors. Now, basically, the collection efficiency of a solar panel is the amount of radiation or photons from the sun that falls onto this panel. Now this is improved by using these reflectors. Now what we have done is we have installed these reflectors in such a way that it is inclined in an angle of 60 degrees. The 60-degree angle is mainly to improve the efficiency, to improve the collectiveness of the solar panel. And what happens is when the solar rays strike this tip of the aluminium reflector, it reflects to the center of the panel. So the amount of rays that come towards this point is totally reflected and made to fall on the solar panel. Similar is the case for this panel, this side of the reflector too. Now, as a whole, it increases the efficiency and the collection of the solar panel is enhanced. This is one of the important parameters in which we have implemented for increasing the efficiency. Talking about the second parameter in solar panel, we have also given the concept of tracking here. Tracking is a pretty old phenomenon, but what we have done is just to add and improve the efficiency. Here we are using a 12-volt 2-amp DC motor. It is nothing but a wiper motor that we use in cars. That is what is installed here, and that can be controlled by means of a keyboard or a keypad. Here, in fact, we have also used the limit switches. That is, when the solar panel moves to, for example, say it moves to the right direction, it shouldn't move after a point, beyond a point. In order to mention the threshold maximum limit, we are using the limit switches. When the solar panel goes to the right side, this limit switch gets triggered, that is, gets on, and the signal given beyond that point, it stops. So that is the use of the limit switch. Similarly, it's given in that direction as well.